Hey everyone, in this video we're going to talk about how do you factor using sum and differences of cubes. So let's get right into it. So we've done factoring polynomials by grouping, and we spoke about that in our previous video. You can see that here in my video section, right? That we did it using for this notation. Well, we did that through grouping because we needed to be able to split into two parts. The first part and the second part. We factored them separately, found what they had in common, and then went from there. And you can watch the other video if you want to know how to factor by grouping. Well, sum and differences of cubes are going to have less terms than this. We cannot do it by grouping because we're actually going to have a lot less terms. We're going to see something like this. ax cubed plus d, or ax cubed minus d. So notice how now we do not have these terms in the middle, and we're just dealing with the cubic function in the top, in the front, the cubic part in the front, and a number at the very back. So we are forced to use a different notation, and what we're going to be calling it here is we're going to be using what we call the SOAP method. Sorry about that. And I'll go into it in a little bit of what this acronym stands for and how we can use it to identify the proper factors. First, we want to be able to address and identify the most common cubes, right? If you multiply a number by itself 3 times, you will get a product. 1 times 1 times 1, for example, is 1. Or 10 times 10 times 10 gives you 1,000, right? These cubes are actually coming from a root number, or the cube root of that number, giving you 7 for 343. The cube root of 512 is 8. So very similar to square roots. Square roots, we find 2 numbers that multiply to give you that number. Like 100, for example. The square root of 100 is 10, because 10 times 10 is 100. Well, here, in a similar form, the cube root of 125 is 5, because 5 times 5 times 5 gives you 125. So I like to make a list of common cubes that we're going to be going to and talking about in order to refer, so we can point out what cube the number is rooting from. Okay? The more you use these, the more you see these, the more comfortable you're going to start getting to how to identify these common cubes. So let's say that we have this problem as an example. Factor the following polynomial. So here we have a cubic function, and since we only have 2 terms, we're going to be using the sum and differences of cubes. We're going to use SOAP method. Now, since we're subtracting, I'll walk you through an example of how to do it, and then I'll break it down slower and show you how to do it in the next couple ones. So what I want to first identify here is I want to identify where this is coming from. I'm going to want to rewrite this as x cubed, or actually, let's write it here on the side. This is the same thing as saying x cubed minus 6 cubed. If I look at my list from the previous page, right, or my previous slide, I have x to the 3rd power, and 6 times 6 times 6 gives me 216. So knowing that the cube root of these 2 terms is x and 6 is very important. These 2 terms, the x and the 6, is what's going to help me identify and set up the factors of what's going to be coming next. So what I'm going to do is I'm going to set up 2 terms. The first factor is going to be a linear factor, and the next factor is going to be a quadratic factor. Why? Because x times an x squared will always result in x cubed. So in the first term here on the left, this first factor, I'm just going to copy down that problem as is. I found my cube roots to be x and 6. Since this problem is a minus problem, I'm going to go ahead and write it as x minus 6. Okay? This is my first term. Then I'm going to have to multiply this linear term, this x, times an x squared to get to the x cubed. So everything in here, I'm going to have an x squared. Now my general form of a quadratic is written in the form of ax squared plus bx plus c. This is my general form of a quadratic. So I'm looking to find 3 terms in this second factor to give me this expression. And this is how I do it. I'm going to start by squaring this term. X to the second power is x squared. I'm going to do that to the last term. 6 to the second power is 36. To find this term in the middle, I'm going to multiply these two terms, and I'm going to say x times 6 is 6x. Now I'm still missing symbols, the plus, minus, and stuff between these three terms, and this is where the SOAP method comes in. The SOAP method is an acronym that means same, opposite, and always positive. And it's referring to the symbols and signs that you use. So, since this original problem is a minus problem, I'm going to use the same symbol to begin with. So I'm going to put a minus. The next symbol will be opposite. So if I started with a minus, I'm going to change this to plus. And then lastly, the last symbol will always be positive, so a plus. Notice here how I have two factors, a linear factor and a quadratic factor that multiply together to give you just that, our original problem, x cubed minus 216. If you want to do box method, you can multiply these two and see how it actually results in that notation. But this is how you do the sum and difference of two cubes using the SOAP method. Let's try another one. Again, I want to identify here my cube roots of these two notations. So I want to be able to recognize that this actually stems from 3 cubed x cubed plus 2 cubed. 3 times 3 times 3 is 27. X times x times x is x cubed, and 2 times 2 times 2 gives you 8. So if you write it this way, you can identify your three terms that you're dealing with, 3x and 2. The purpose of identifying these cube roots, remember, is because these two numbers is what's going to help us manipulate and get the rest of the factors. The first set of factors will always be the problem as is. 3x positive 2. I'm going to use the factors that I found, the cube roots, as the notation. The rest will be a quadratic. Okay, now I can even fill in the rest of the symbols already before I begin. I have SOAP method. So, same. The problem is a plus problem, so I start with a plus in here. Opposite means I'm going to flip the sign to a negative, and the last one will always be a plus. Now I can just fill in the 3 blanks. I can fill in the blanks in here, here, and here using the rest of my factors. So step 1, find the cube root, plug them into the original problem. Step 2 is do the next step. So we're going to square the first term, put it in the first space. Squaring means this. It means that I have to take this first term and square it. So I have 3 squared and x squared, which results in 9x squared. And then I take the other term at the back, and I say 2 squared. 2 squared is 4, and that's how I get this term right here. So I square the first term, put it there, square the second term, put it here, and to find the last term in the middle, we multiply these two terms. 3x times 2 gives me 6x. And there you have it. We have two factors. We have our linear factor multiplied by our quadratic factor will always result in a cubic expression. X times x squared will give us an x cubed. So I can always count on having a linear form and a quadratic form to result in this notation. Let's try one more just to solidify this. Why don't you press pause here or stop and then give this one a try, and then we can solve it together. So I want to identify where this problem stems from, right? What are the cube roots of my situation? I technically have 2 cubed x cubed plus 5 cubed. Knowing the cube roots will allow me to solve my problem because it identifies the key components of what I will be using. So I'm using 2x and 5. Before I start, let's use the SOAP method and fill in the spaces. So same, the original problem is a plus, so the same sign will be a plus. Then it's the opposite sign, so minus, and the last sign will always be a positive, a plus. Now that I have my spaces, let's plug stuff in. The first term, I plug things the way they are, 2x and 5. I found my cube roots from identifying these three terms, and that's going to go in my first factor. Then I'm going to square these. I'm going to square the 2x. So 2x times 2x gives me 4x squared. I squared my last term. 5 squared is 5 times 5, or 25. And then the last term in the middle, I'm going to multiply them. 2x times 5 is 10x. And that is how we find the factors. If I were to create a general formula or a general sense or idea of how to follow this, this is what it would look like. So you could have a general form here, like x cubed minus b cubed. Now you could technically also have a number in front of the x cubed. You could have a number in the front, an ax cubed, right? It could just be x cubed minus b cubed, or it could include a cubed, x cubed minus b cubed. You could have numbers in front of the x. First, I identify the problem in this notation. Find the cube root. That's my first step. Find the ax and the b that this number is coming from. So you most likely won't see it as b cubed or a cubed. You'll see it as 125 or 64 or 343 or some larger number. You're going to break it down to find the cube root of it first. Step number 1, cube root. Then I would set up my problem using SOAP method. Set up the signs. So SOAP method stands for same, opposite, always positive. So if the original problem is a minus, you're going to start with the same symbol, a minus. If the original problem is a plus, you put a plus. Then you flip it. The opposite becomes the opposite sign. And the last one, no matter what, will always be a plus. It'll always be positive. Once you identify your linear and your quadratic factor, now it's time to plug in the numbers themselves. So on the first factor, I'm going to plug in the cube roots that I found. So I'm going to plug in ax and b. The next factors are the ones where we actually do some math. So here I'm going to square this first term. Squaring this first term means I have to multiply it by itself twice. If I'm squaring it, that means that I'm going to have a squared and an x squared. I'm going to do something similar to the back. I square the last term, which gives me b squared. Now, a and b are going to be numbers. So if you have 2 squared, you replace it with 4. If you have b squared as like 5 squared, you replace it with 25. These are just general forms. To fill in the spot in the middle, I'm going to multiply my 2 terms and fill in that last middle step. So ax times b will result in some sort of number x. So I'm going to say it's going to be abx. We're just multiplying ax times b. And this is exactly how you would find the general form of any method, of any cubic function where you're using the sum or the differences. Sum and difference comes in from here. This would be a difference of 2 cubes because it's minus, so you start with minus. If this was a sum, you would have said plus, and that would have started with plus because of the same, opposite, always positive. I hope this helps. I try to break it down as much as possible. Please let me know if you have any questions. If you have not subscribed, let's go ahead and do that already. And as always, guys, we'll calculate later.